Testing, testing, testing. Uh, Good morning, everyone. My name is Paweł Gładysz, and I will be today the chair of this special session on the CCUS. I will kindly ask you all to wait 2 or 3 more minutes before we actually start, as we are waiting still for some stationary and online participants. Thank you. Okay, good morning, everyone. Again, my name is Paweł Gładys, and I will be chairing today's session. And before we move to the presentation, I would like to also welcome you on behalf of Professor Nowak and Professor Bukowski, both from IGH and Visa Europe Institute, who are supposed to be with us today, but unfortunately, due to the other duties, they couldn't come. So I will be chairing today's session and giving presentations on the overview of the CCUS project and the process modeling, as well as a few words on industrial projects and the CCUS cluster. And our colleagues from Visa Europe Institute will tell us about the energy system modeling and other project that is related with the CCUS development in Poland, the CCUS.pl. So I will then, without any further ado, we'll go to the first presentation, which will be the overview of the CCUS project. And so before we actually go to tell you all about the CCUS project, I would like to start again with a small slide that tells and explains a little bit how it all started. The key point here is that we are at the point of having to make a decision about the CCUS implementation. And already in 2019, Global CCS Institute has published a report stating what is the global CCS readiness index and what is the CCS readiness index for each of the countries versus the CCS inherent interest in the technology. And Poland scored somewhere around 62 points in terms of inherent interest, and the readiness level was assessed of around 42 points over from 100, which positioned us in a group of these countries that are still underdeveloped in terms of being ready for the CCS implementation. We are looking at the countries like Norway, like United Kingdom, Australia, Canada, and USA, who are the forward runners of the CCUS technologies. And when we looked more in depth into the CCS readiness index for Poland, we noticed that our geological CO2 storage potential was assessed quite high, which also is proved by our project right now. The legal framework was also quite high assessed, 51 points over 100, which mainly actually came from the EU legislation on CCS. But the policy development was marked very, very low, and this did not change over the time. And our project basically answered this need for the policy development for CCUS technologies implementation in Poland. When we are looking at where we are now, we want to move forward. And the ways are that we can increase or decrease the inherent interest in the CCUS technologies depending on other policies. So when we are thinking about it, we are thinking about the hydrogen strategy, the RES development strategy, the nuclear energy strategy, that can, in a way, decrease the interest in the CCS technologies. But on the other hand, we have policies like net zero by 2050, which would probably actually increase the interest of Poland in the CCUS technologies, especially in this term, in the need of negative CO2 emission. The reindustrialization policy would also move the interest up, and the prevention of carbon leakage strategy would also include us in the group of countries that would need to develop a CCS strategy and include the CCS technologies in their energy mix and economic activities. But the main point is that we need to move forward, and we are at the point where the decisions need to be made. Our project was granted from the program CCUS.pl of the National Center of Research and Development, and we started the project at the end of first quarter of last year, and the duration of the project is 36 months. So as you can see, we are exactly in the middle of our project execution. The project is done in a consortium of IGH University of Science and Technology, which is the leader of the project, as well as the Visa Europe Institute, which is the independent think tank supporting us in terms of policy and modeling framework. We also are cooperating within a consortium with the Ministry of Economic Development and Technology, which is the implementing entity. Although I would also like to mention that we are currently in the process of changing our implementing entity to the Ministry of Climate and Environment, which is right now mainly focusing on the CCUS strategy development in Poland. And that's why we are hoping to change the consortium partner but also still cooperate with the Ministry of Economic Development and Technology, especially in the terms of support schemes for such a systems. The acronym of our project is CCUS.pl, which is also the address of our webpage that was launched lately. And what are the main project goals of our is first of all preparation of the strategy for the development of CCUS technologies in Poland. Next to it, this is the appropriate legal and regulatory framework that will stimulate this development, and also the preparation of the first Polish CCUS cluster. But CCUS cluster understands it both ways, as an organization, as a group of people, of interested stakeholders in further development of the CCUS technologies, as well as proposing an actual cluster or hub that could present the whole value chain of the CCUS technologies in Poland. There are, of course, other goals, and in the first phase of the project, in the first 18 months, we were rather focusing on the research tools that will support us in terms of how we will develop the strategy, how we will animate the discussion, how we will communicate the CCUS technologies to the stakeholders and general public. And this is what we are actually right now focusing on. But of course, other goals are the reports and studies and other dissemination activities which are planned within the project, and most of them will happen in the upcoming 18 months of our work. When we look at the phase A, so the first 18 months, the main outcomes from our project are the database for the CCUS technologies, the assessment methods, both for individual installation as well as the clusters and hubs, as well as something which we call right now a universal process model for simulation and optimization. And our colleagues from Visa Europe Institute are focusing on the national level fuel and energy model, as well as a macroeconomic model that would include the CCUS technologies. So this is the main outcomes of our project. I can already skip a little bit ahead and say that we met all the goals of our project for the first 18 months. The next 18 months, already with the involvement of the ministry, states and are reflecting in the main project goals, which is the strategy and the draft legal and regulatory framework on the side of ministry with the support of Visa Europe and AGH University. And our specific goals for AGH is the technological procedures and guidelines of how to do CCUS in Poland in the specific cases for specific industrial sectors, and how to cluster this, how to animate the discussion, how to help and support the development of hubs, which is also part of the Polish CCUS cluster, and a lot of different dissemination activities. And our colleagues from Visa Europe will provide us with the quantitative and qualitative analysis of the CCUS technologies and the report supporting the implementation of the strategy, as well as something which is very important, I believe will be one of the most important challenges for us in the project, is the information policy framework. So how to address the general public in terms of how to communicate the CCUS technologies to the general public, and try to persuade them that this is a safe and good option for Poland. When talking about the project, I should also mention that, as I mentioned before, the Professor Wojciech Nowak is the Research and Development Project Manager. I have a pleasure to be the General Project Manager. And in AGH University, we have over 40 experts divided into 3 research groups that are working on different areas from the technological or economic point of view. For the technological research team, which deals with capture, utilization, transport, storage, as well as power industrial installations. Comprehensive assessment research team from economic and environmental point of view, as well as risk assessment, but they are doing this on the level from the investor point of view, right? And of course, process modeling research team, which is responsible for the model development, simulation, and optimization studies of the potential CCUS clusters. Visa Europe, I guess they will be able to tell us a little bit more about the research team, but I can see there are over 10 experts in macroeconomic and system models, experts in Poland in terms of what is planned to be done. And so I would like to thank you for your attention in the introductory part of our project, and I will move now to the first part that is associated directly with what we have been doing in AGH University, from the process modeling, simulation, and assessment of CCUS technologies and clusters, which is basically a summary of the 18 months of our research. I will, of course, show only a fragment in case of examples, as a lot of work has been done. More and more of the work will be soon published on our webpage, and I would also like to address our colleagues from abroad that unfortunately in the first approach we will publish in Polish because the project is dedicated for the Polish stakeholders, although we will definitely catch up with the English outcomes of the project in order to also include the international stakeholders of the CCUS technologies. And so, as I mentioned a couple of minutes before, our goals was the technological database, the assessment methods, and the universal process model. But before we go to that, I would like to point out what kind of technologies are we dealing with when we are talking about the CCUS. So first of all, of course, the CO2 capture from power and CHP power plants, and we are from taking into account the current situation in Poland. We are mainly focusing on retrofits of existing plants. We were, of course, at the beginning when the project was submitting, we were thinking about also including a wide range of options for newly built plants, for example, natural gas combined cycles with CCS, but taking into account the current changes in the gas market, it might not be that feasible option, but we'll of course take a look at this. And of course, the technologies that are important for our country, which will be, for example, the internal gasification combined cycles with CCS as a newly built power or CHP plants. We are, of course, looking at the CO2 capture from the industrial sources. Of course, starting from the ones that have the biggest potential, like cement industry, going to further like refineries and other sources of point emission. We are also looking at the integrated steel mills, as well as other options for sources of CO2 that could be captured, for example, from petrochemical industry or chemical industry or aluminium. And when we are talking about the capture, we should also mention that there is a lot of focus put around the bioenergy with CCS. So a capturing of carbon dioxide from the sources that are using and utilizing biomass as the feedstock in order to obtain in the end the negative CO2 emission. This is one of the biggest points, and this was actually one of the drivers of the project as well, together with the lack of policy in terms of CCS, is how to provide an effective negative emission and how to reach to the net zero but by 2050. And that's why the examples I will be talking about will be directed and focused around the bioenergy and the other branch that can provide us with the negative emissions, which is the direct removal of CO2 from the atmosphere, so the direct air capture and the methods of its integration within the industry, within the industrial processes. So this is on the side of capturing, and then what to do with the captured carbon dioxide. Well, first of all, we would like to include a wide range of options for industrial use of carbon dioxide. But of course, we are talking about rather smaller scale in terms of the options. Nevertheless, the hydrogen economy could be a great point of integration, production of synthetic fuels. Maybe the enhanced oil and gas recovery are not the best suitable options for Poland, taking into account our geological conditions as well as the enhanced coal bed methane. But mineralization option is also considered. When we are talking about the industrial use of CO2, nevertheless, even if it's associated with close by to the source, there is a need for transport. When we're talking about transport, we are talking about the various scale and distance. Of course, the main focus is put around the big scale CO2 hubs that could actually integrate a carbon dioxide capture from a lot of different sources located around the specific area. And we're talking about the overground and pipelines. We're also thinking about the subsea pipelines as well, tankers and systems and other ways of transporting carbon dioxide from the emission point to the utilization or storage point. And when it goes to storage, we are not looking at the specific technologies in terms of getting too detailed into actual process modeling of it, but rather to say what are the locations for CO2 storage in Poland, what is their capacity, what would be the cost, what kind of options we have in terms of being able to drill to that point and be able to provide a safe storage and monitoring. But we are also looking at the cross-border cooperation and CO2 storage hubs. So, for example, in our analysis for the north of Poland, we will definitely try to include an option for shipping or exporting the captured carbon dioxide into the project of the CO2 storage in Norway or in the United Kingdom. And so, at the end of the day, we are looking at the CCUS technologies in a cluster manner, in the hubs and storage, for storage and transport. And with a lot of cooperating units that could actually provide us a big picture, big scale for the CCUS implementation in Poland. Of course, not in all regions everything can be done. Not in all regions of Poland we can talk about the full cluster that would include all of the elements. But in the end of the day, our goal is to look at the technologies, at the CCUS technologies in an integrated manner, rather as was done previously in the past. For example, just one source, one transport route, and one storage site, right? We're trying to look to minimize the cost, to get the effect of scale, to get the synergy effects of such a systems. And so, going to what has been done in our work packages, where the first work packages ended already some time ago, and all the milestones have been met. It would include a technological database with over 40 cards, but this is something that will be further developed and extended over the project. The cards are prepared right now in Polish, and we're in the process of translating them into English. We're also open to trying to provide a template for such a card to our industrial partners and stakeholders for them to also fill out their information and provide the information about their technologies, their options for within the CCUS chain. This is something that will be done under the umbrella of the CCUS cluster, and hopefully we will soon start to disseminate the results through our webpage and through direct respond to questions regarding, for example, the capture options for a specific source. We also were working on the direct assessment measures regarding the energy, economic, and environmental impact. And those measures were used as part of the technological database, in which we actually include the results from the point of view of energy, economy, and environment to those technologies that have been considered. Of course, the important thing for us is right now that we are doing it for Polish conditions. Well, right now we are at the point that we are thinking we should not update especially the economic points of view in terms of assessment. But we are thinking about going two ways and providing what was already done for the data from 2021, but also provide an update for the parameters, especially the economic parameters for the actual macroeconomic environment. Regarding the work package 3, it's still in progress, but of course it ends by the end of September 2022. And first of all, we were working on process model of CCUS technologies in different software. We were working mainly in GPROMs, but also with HEMCAT, CPOTE2022 Professional, and AllCode to provide process models of different elements of the CCUS chain. We try to also integrate them into one model through the GPROMs software. We're also preparing assessment measures for CCUS hubs and clusters, but they are usually the same measures, just on a different scale. But this allows us to calculate the cost of CO2, for example, capture in any situation when we have individual source, individual pipeline, individual hub, and compare it if it would be a part of a CCUS cluster. And in the end, there's something that goes a little bit beyond the scope of the proposal of the project, is that we would like to put the results of the process models and all the assessment measures and put them in a universal Excel-based model for comprehensive assessment and optimization. So a tool that would, in a way, allow the users to introduce their kind of technologies, then add the CCS components into it and calculate, for example, in a simplified manner, of course, costs associated and environmental impact and other factors that have been described in our assessment measures. We were a little bit inspired by our colleagues from Central Mining Institute that had done such a tool for the Silesia region. We are also inspired by our colleagues from different Gospodartex projects. Our also goal is to provide an actual tools to the general public and let them be able to, in a way, play a little bit with the numbers and see what happens. And this, of course, will be published both in Polish and English, hopefully by the end of the year, as it a little bit goes beyond the original scope of the work package 3. I would like to mention also that one of the best tools that we recognize as a tool for process modeling and optimization of the CCUS clusters is the GPROM software, which allows us to not only look at the plant from the individual point of view, but also try to integrate several routes into one system, transport system, and then 1 or 2 storage hubs. But it also gives us a chance to go very detailed into process modeling and then go up and up in the level of assessment, still using a very detailed models of the plants. But of course, this is not something that can be publicly available, and that's why the results of those analyses for different specific technologies will be transformed into the simplified universal Excel-based model. But in the end, we would like to use the GPROM software in the second phase of our project to actually do a full study of a specific CCUS cluster in Poland, in which I will say a few words more later on. As we already invest a lot of time and effort into getting familiar with the GPROM software, we have at AGH a team who is experienced not only in the process modeling and different tools, but also in the GPROM software itself, as we went through an extensive training by the software provider. And so, as I was mentioning at the beginning, I would like to show just a small fraction of the results referring to the issue of negative CO2 emission, so the modeling and assessment. I will, of course, show just a few slides regarding the CO2 transport hubs and geological storage and geological formations, but I believe that the negative CO2 emissions are rather much well accepted and recognized by the international community in terms of CCUS implementation, rather than in many cases including the CCUS in the fossil-based power generation sector. So it's more, let's call it, neutral topic. And just to make it clear, when we are talking about CCS on the fossil fuels, we are going from negative to somewhere close to the neutral impact of the technology on the climate change. We will never be able, relying only on the fossil fuel extraction, to get actually to the neutral point, taking into account, first of all, that not all CO2 can be captured. Goes from the technological reasons, but also there is a whole chain of CO2 before the fossil fuel extraction, all associated with the fossil fuel extraction and the capture itself, which means that we'll never reach to the neutral level in terms just with a simple CCS on fossil fuels. But if we would now take the same plant and try to add biomass to it, we would be able, and include the CCS, we would be able to go to somewhere from neutral or somewhere from between negative and neutral to something which we call climate positive. There are issues regarding how to call negative emissions, because we're talking about negative emission, and I'm talking that they have positive impact on the climate change. But in general, we are looking at the point in which we would actually be having a technology that could take the CO2 from the atmosphere in order to slow down, or to even maybe in the really distant future, but still reverse the climate change. So this is the industrial application of bioenergy CCS, or bioenergy industry with CCS. And we believe that this is a very good option to get the than the required negative CO2 emission. But there are, of course, other options. Other options, as I mentioned before, are the direct air capture technologies, in which we capture the CO2 from the atmosphere and then we store it, which is basically a positive option in terms of climate impact, the climate change impact. We can, of course, and there was a lot of proposed projects like this, that we capture the CO2 and then we produce the synthetic fuels, and then the CO2 is released back. So we are somewhere, I would say, before the neutral, because there is some kind of energy consumption, material consumption in the process of direct air capture installation itself, but also the utilization. But still, nevertheless, it is an interesting option, especially for example, aviation fuels. And then, of course, instead of storing the carbon dioxide, if we have an issue with the CO2 sequestration, we can try to utilize the carbon dioxide into, for example, a solid state and use it in the cement or concrete blocks. And then we can say that the CO2 was actually still removed from the atmosphere in a predictable time. It has an impact, positive impact on the climate change. So as you can see, there is a lot of issues associated with the obtaining of the negative emission, and we're trying to provide a solution that could be positive to the climate change. Of course, there are other options, for example, the natural approach like afforestation or reforestation, soil carbon sequestration, or biochar. When we move forward to the technological solution on the scale, you can see that we have biomass carbon removal and storage, carbon mineralization, and direct air capture. When we're talking about the bio-CCS, we're basically talking about the biomass that is being used in a plant, in a power plant, industrial facility, where the CO2 is captured and then stored, and then we use and utilize the useful products like heat, transport, power industry, and whatever else. And in terms of direct air capture, we're talking about ambient air going into the installation, and then the CO2 is captured, and then is ready for storage. This will, of course, require a significant amount of energy that needs to be introduced into the system in the different forms. And we actually analyzed 3 different options here regarding how the direct air capture installation could look like. But I would start with the options for bioenergy CCS for power plants. And we tried, as I mentioned before, to analyze, first of all, the retrofit options. So the retrofit options, which allows us to look much closer into the topic of what we can do with the existing infrastructure. So first of all, we decided to analyze 3 different plants: Łagisza power plant, which is currently hard coal-fired, Bełchatów power plant with lignite, and Połaniec power plant fired with biomass. We built a simulation of models for each of the plant, and for each of the plant, we propose a different strategy to include the biomass in the first 2 options, and then to add the carbon dioxide capture installations. So for hard coal and Łagisza power plant, we assumed a biomass co-firing up to 30% in the mass. Then we also looked at the lignite Bełchatów power plant, and we propose an option of dual block, in which we decide to add a smaller, up to 40% biomass share dedicated boiler that will work on a common line with on the common pipeline, let's say, that combines the steam from the lignite and from the biomass fired installation. And then, of course, we have Połaniec, which is already dedicated for the biomass combustion. And so, in the end of the day, we have also a different scale of those plants, although we are not here showing the results for large-scale plants that were also analyzed, like, for example, the newly built Tauron block in Jaworzno. Some assumptions, as we are on the scientific conference, and it's usually important to mention how we did the study and what kind of assumptions we did. Well, we are showing the results for MEA post-combustion capture installation with something around 3 megajoules per kilogram of captured CO2, reboiler heat duty, and 130 Celsius degrees operating temperature. We were analyzing, depending on the case, the different points of collecting this required steam from the steam cycle, as well as using the heat integration, the option for heat integration of waste heat from the system back to the power plant in order to increase its efficiency. And on the other side, as I mentioned before, direct air capture installation and three different options. First of all, first one is the high temperature aquariums, which used mainly direct electricity demand. And then the low temperature solid sorbent solutions and two sources of heat, waste heat, which we assume comes from industrial installation, which is actually a heat that would be otherwise rejected into the environment, and a heat pump as an alternative source of heat required within the direct air installation with solid sorbent. Of course, we still also have a significant consumption of electricity inside within the installation. And of course, the difference is here also the capacity that the installation could provide, from 1 million tons of CO2 per year for high temperature aqueous to 360,000 tons per year for the low temperature solid sorbent direct air capture installations. And so we did the process modeling. Maybe I will go back here. We did the process modeling on that, supporting a little bit with the literature. We tried to recreate the models as it is. We did so far the analysis for the steady state, so the nominal load operation, especially for the plants, I guess this would be important. But nevertheless, the models have been developed and integrated and analyzed, and the results of the simulation were used in the assessment method. So there are also some of the assessment methods that has been identified and described by us. And we have, for example, the specific primary energy consumption for CO2 avoided, the SPECA. I know that everyone who is working with CCS is familiar with this one. And of course, the really simple ones, like, for example, the loss of net energy efficiency in terms of power plants. When we look at the issue of are we actually getting a negative CO2 emission, it's very important to assess, are we actually providing in a given moment a negative CO2 emission, taking into account not only what is happening in the plant, but also in the full chain, let's say a life cycle approach. And that's why we identified the carbon intensity and the carbon removal intensity factors, as well as just a simple calculation of the negative emissions coming from the including the total emissions in the whole chain. So we also took a data regarding, for example, the cumulative CO2 or greenhouse gases emissions, to be precise, for given products or energy carriers used. So this is the one approach that uses the CI or CRI factors, and we also used one that is recognized in the literature, the carbon to atmosphere factor, which also allows us to say, are we dealing with a negative emission or are we not dealing with a negative emission? And so how to interpret those indicators? If this indicator is between 0 and 1, the carbon to atmosphere, or the CI or CRI are lower than 1, that we have a potential for carbon dioxide removal. So the process might have a positive impact on the climate change. So it could help have the mitigation effect. And we can also say that we are actually dealing right now with the carbon negative emission technologies. If the values are 0, we are actually talking about the potential, about the neutral approach. And when the factors are higher than 1, or between 0 and 1 in terms of the C2A factor, and CI or CRI above 0, then we are talking about the potential for emission reduction when it's compared with the reference plant. Or we can actually have a situation in which we'll actually in total full chain emit more than we did in the previous case. This is very important to recognize, and that's why we're also using the C2A factor, which allows us also to identify, are we adding more carbon dioxide in the full chain, or are we actually providing some kind of reduction? Next to the, as this is also a scientific conference, and we are also dealing with, for example, thermoecological cost, we also, from this point of view, decided to include such a factor. The thermoecological cost basically describes as the depletion of non-renewable natural resources. And so we figure out how to calculate the specific thermoecological cost of obtaining negative CO2 emission. So how quickly we will deplete the non-renewable natural resources while at the same time providing the needed negative emission. And we did the analysis, of course, for the Polish conditions. In terms of economics, we use the recognized measures like, for example, the levelized cost of electricity or the levelized cost of CO2 avoided. But we also introduced the levelized cost of negative CO2 emission into our calculation in order to say which is the cheaper, which is the more expensive option. And so showing the results of energy assessment, the HC refers to the hard coal, red considered the retrofit option with the CCS, the L goes to lignite, and the bioenergy goes from BE. And you can see the graphs are presented in the biomass share. So as I mentioned before, for the Łagisza plant, we had from 0 to 30% of biomass share. And so we can see a significant decrease in net energy efficiency, and also the value of SPECA of around 3.6 megajoules per kilogram of CO2 captured. When we are talking about the technologies that are associated with dedicated for bioenergy, we can see here that the retrofit, the net energy efficiency drop is higher in terms of retrofit of biomass-fired power plant with CCS, although not that significant. But the value in general, the value of SPECA could be a little bit lower if we decide to actually build new one, or a little bit higher if we decide to retrofit. And of course, the least favorable option was doing anything with the lignite plant. So even the dual block and adding the CCS was not too much favorable option, especially from the energy consumption point of view, especially with the high SPECA value. Then we try to see if we actually achieve a negative emission. So everything, as you might recall, everything that is below the 0 for the C2A parameter is actually a negative CO2 emission. So we put on the graph here, first of all, the direct air capture, and you can see that one option here, the one line here, because it does not rely to the biomass share, is way above. This was the direct air capture with high temperature, but taking the electricity from our national energy system. Our national energy system, as in Poland, is basically based on coal. So using this technology would actually add, well, it is some kind of reduction, but in the end of the day, it's not an actual goal of the direct air capture installations to provide the values over 1. But we also analyzed the system in which we said, okay, but what we would actually merge this installation with wind turbine farm. And then in the end, we would actually get to the point which we needed. So a very low value of the C2A. So actually the role of the direct air capture would be met, would provide a negative CO2 emission in the full chain of analysis. The lines here are showing the effects for the power plants. So as you can see, around 18% of biomass share. We are actually starting with, for the plant with CCS, we are starting to obtain negative emissions, right? So we are somewhere around here. If we do the CCS on the plant without the biomass share, we can see with the biomass share, but without CCS, we are of course decreasing, but we are still above the value of 0 for the C2A indicator. And so, of course, when we look at the 100% biomass of the dedicated units, we can get a very similar result to the direct air capture, that is where the electricity is provided by the dedicated wind farm. The numerical results are presented here, and we can see what I mentioned before. If we use the electricity source from the national energy system, we actually have the added value for example, CRI, which is the value of kilograms of CO2 per megawatt hour of electricity consumed. And so we also look from the depletion of non-renewable natural resources point of view. This is something that merges the environmental impact with the energy impact, with the exergy as well. And we also show that from the point of view of retrofitting the existing plants with the biomass, we get a very high value of the depletion of non-renewable natural resources. So it's much better to build a dedicated biomass-fired plant, because we are actually having a 100% biomass combustion here. So there is no depletion of non-renewable natural resources in the process of combustion, let's say. But when we look at the direct air capture installations, we can see that definitely using a Polish national energy system as a source for electricity for those options is very not favorable. And so definitely for now, the direct air capture installations in Poland, when combined with the grid, do not make too much of a sense. When we decarbonize the electricity production sector, then it's a point to actually bring, even for the technologies that use the low temperature solid sorbents and use, for example, waste heat, still the value is much higher than, for example, for the dedicated bioenergy power plants. When we look at the economic assessment was done on the prices presented here. So you can see a little bit before at the beginning of 2021, basically. So of course, the direct air capture, the prices go down, the net present value goes down. This is not effective, economically effective right now. In terms of power plants at those given prices of CO2 and so on, this is also not favorable. But this is also the case when we don't pay extra for the negative CO2 emission, which is an important assumption here. In Europe, in Poland and in Europe, there is no actual acknowledgement of the negative CO2 emission in terms of, I don't know, associating it with the EU ETS. The work is ongoing, and hopefully something like this will be included. No, okay. So we actually looked at what is the relative change, so the multiplication of the assumed CO2 emission allowance price for two different direct air capture technologies in order to get the profitability on zero, so to get the net present value equal to zero. So as you can see, we would have to get something around 130 150 euros per ton of CO2 for the direct air capture low temperature installation with waste heat. And of course, the value is the multiplier is 4.5 for the technology that would use a heat pump. So as you can see here, there's a definitely need for acknowledging the fact of obtaining negative emission and paying extra for it compared to the EU ETS system right now. This is something that needs to be addressed if we want to deploy the negative CO2 emissions. And of course, we higher the costs for the direct air capture installations compared to the dedicated retrofitted power plants, and especially to the newly built bioenergy power plant, in which we get the lowest cost or levelized cost of negative CO2 emission. And we of course try to compare all of it on one slide to show where we are. It's very hard to interpret, but just wanted to show that our approach is rather comprehensive, and we try to match as much as possible in terms of assessment options. Try to use the common denominators within the analysis in order to provide a comprehensive answer. Is this or that option suitable or not within the whole CCUS chain? And so this is the summary of the example that I wanted to present. And now I would like to go a little bit to the exemplary results for the CO2 transport. So our colleagues that are dealing with the CO2 transport are dealing with a specific analysis for specific routes, direct as well as hub transport. So we are looking at the possible route. What is the height profile? Are we actually going through any kind of protective area? Are we going through other infrastructural issues, like, for example, going through a highway or through a bigger city with the pipeline from the storage to from the capture to the storage location? Such analysis are usually done case by case, which means that they're rather going to be doing a case study and not in the general approach. We also try to analyze the available CO2 storage site locations through a scoring of potential site. We use the proposed methodology by the Department of Energy from the US, which allows us to score which of the locations presented, for example, here, is the most suitable for receiving the captured carbon dioxide. The scoring system is, of course, still undergoing several improvements, but in general, it shows us that there is a great potential for CO2 capture, mainly in the central of Poland. And so the general conclusions from our tasks and the research done so far In terms of economic, and I think this is the most important one, is that generally the CCS chain is cheaper than paying the EU ETS in the horizon by 2050. So we are at the point in which we could actually try to invest. There are some specific projects that get a very high internal rate of return. There are some with a lower one, but the general conclusion from the studies that we did for different sectors, for different cases, is that we are saying that this is generally cheaper to do a CCS than pay the EU ETS prices. The options for utilization, unfortunately, right now at the current economic market are decreasing the values of the internal rate of return, unfortunately, but hopefully within the time they will become more profitable. What is needed, what we noticed is that the infrastructure operators are needed for CO2 transport and storage, because we also look at the issue of developing the CCUS clusters, not only from the process modeling point of view, but actually from the technical point of view, what is needed in terms of infrastructure and technology to make it happen. And so there is a definite need for CO2 transport and CO2 storage operators that would handle the CO2. As in most of the cases, the responsibility for the capture installation should end at the border and be provided, and then the option should be, the CO2 should be taken by the dedicated companies. Well, in terms of assessing the storage capacity, we definitely have a sufficient onshore CO2 storage capacity, but this requires further analysis, drilling, tests, and so on to actually try to get the actual storage capacity. We are talking right now about the theoretical based on modeling and some core samples analysis, but not on the level of actual capacity coming from tests. On the change in the CO2 storage law, we are definitely looking forward for the same changes in legislation for the CO2 transport, and this, I believe, should also be coordinated on the EU level, as this might, in many cases, be a cross-border CO2 transport hubs. When we're talking about the CCS, we should remember that the CCS readiness or CCS ready status was already enforced for power plants that were built after 2000. 12, thank you, President. Yeah, something like this, skipped my mind to be exact. But in general, we have several plants that are theoretically CCS ready. We did some of the studies for their locations, and we realized that despite that they have the status for CCUS ready, it might be very hard to, I would say, squeeze in all the required infrastructure. So the capture installations, the CO2 processing unit, the CO2 compression unit. The availability of space, despite the CCUS readiness status, might not be sufficient, which would actually should force the companies to provide a compact solutions for carbon installations. And this is something that I believe is provided right now, for example, by one of the companies from Norway with a modular solution. And from the point of view of how to introduce the CCS in Poland and launch the CCUS projects in Poland, I believe, and this is my, let's say, opinion, as I am giving the presentation, I will allow myself for one individual comment, is that we need technological and organizational integrators, a company that would come to Poland and support us in terms of developing the whole CCUS chain, take some of the responsibility, bring the technology and bring the know-how of how to do it, so we can fastly develop the CCUS chains in Poland. Otherwise, it might take us a little bit longer than needed. And the upcoming tasks of our work package, well, we are definitely preparing we're launching slowly the first CCUS cluster. We will be having a lot of dissemination activities, which I will talk more about in the last presentation. Right now, we will start switching from a general process modeling to the process and design analysis of potential CCUS clusters and include them in the comprehensive assessment and optimization. So we are going to be seeking for actual options for clusters and hubs in Poland, taking into account the stakeholders of our organization and try to provide, based on those analyses, a technological and organizational guidelines for CCUS clusters and hubs development. So our goal is to provide the answer of how to do the CCS in Poland, the specific of the Polish reality. Thank you very much for your attention. Now I would like to welcome our colleagues from Visa Europe Institute to give us a presentation on what they have been up to for the last 18 months.
Thank you very much. My name is Marcin Jaskowski. I work at Gdańsk University of Technology, but today I will speak as a team member of the Visa Europa Institute, who actually does some activities in this project as well. So let me also ask to say a few words about Visa Europa. Visa Europa is a think tank that's independent, based in Warsaw, focusing on the socio-economic and foreign policy analysis. It also is authored some of the reports on different topics like energy and climate, economy, which are here presented. CCUS.pl is, let's say, threefold. The first is the communication, so the area implementation of CCS technology in Poland, communication. The two other are more technical. We developed two different models. Why two models? One of the model is a typical energy system optimization model, more technology oriented, but neglecting the other sectors of economy, while the other focuses on the whole economy, while simplifying the energy system to, let's say, black boxes or even more simplified form. So as to the communications, some major area of communication activities is the website CCUS.pl that is already operational. This is the main dissemination channel for the project results and undertakings. Also, the role of Visa Europa is to issue scientific publications, also some reports, trade publications, and newsletters. There's also another area of activities which is more like internet related, so increasing the awareness of CCUS technologies over the social media, over interviews, participation, social and business events. So this is more or less the communication area that Visa is contributing in this project. As I mentioned at the beginning of the presentation, I am in a team developing the energy system optimization model. Michał, who is also a co-presenter here, is our leader of the group. We also have one member who's not present today, who is Juran Skrzypek from the Jagiellonian University of Krakow. And we call this model Pol Times. Why this name is Pol? It's of course Poland, and Times. Times is the tool that we use for developing this model. It is a very well known tool. The acronym stands for the Integrated Markov system, and it is a kind of I wouldn't say a merger. I would say it takes the best characteristics of two previous models. Markov, developed in the early 1980s. The acronym is Market Allocation Model, and the FM Energy Flow Optimization Model. Both models were used very widely by a network of scientists and organizations like International Energy Agency and European Commission. Okay, so energy system modeling, or I call it energy system optimization model because actually the Times model belongs to such a group. What we've achieved so far. So initially we had to well, choose a tool in which we will develop the model. So after some studies on the existing tools and implementation of the model, we decided that we will pursue the option of times. Times is a mathematical structure of the model implemented in general algebraic modeling system. There are different implementations of times models, but the most developed, I think, most developed for the European regions or European Union is the GRC EU times model. So it is a ready implementation. So if such implementation exists, we said, why not building on that implementation of the model? That would, of course, allow us to focus on what is important for the project. So what we achieved is we recognize the implementation of this model in Beta 2.0. Beta is a user interface. The use of this interface is actually necessary in order to deal with the model because of its complexity. So we started to work with this, recognize it. I had some prior experience with a Markov model, which helped me very much because at least I was able to follow what are the parameters, but actually the number of technologies implemented in GRC EU times is like enormous. So it's difficult to even to remember all of them. Okay, but we mastered this Beta 2.0 implementation and the tool so that we were able to introduce some extensions, some modifications. So that would be our contribution to the project and to the modeling in this project. So what we've done is we mostly implemented new technologies. So we are able to implement new technologies, some user constraint, some rules and scenarios. And we actually ran some scenarios, like two scenarios were prepared. One was baseline, which was ready, and one was our modification of an existing scenario, which we call CCS scenario. Why? I will explain a little bit later. Also, as I mentioned, two models are developed, and the one of the product will be the merger soft link. I would say it's soft link. It's not a hard link because hard link would mean that both models are implemented in the same platform and they exchange results between each other. So the results of one model are the input to the other model, and vice versa. Since the models are developed in different environments, we decided that it will be a soft link, iterative soft link. So we will work on that. Some results will be put into the CGE model, and the CGE model will output will be will serve as an input to the times model. Okay, so we had to recognize what are the connection points, what are the common ground for both models, and this is also not easy because the complexity of the model is some kind of a problem. It is also a big advantage of this model because, as you can see, we can already have some results, preliminary, but in fact, it creates some difficulties as well. Also, the implementation of GRC EU times. This model was developed by GRC over the years, and its calibration is for the year 2010, which of course requires some refinement of data in order to include all what has been built since 2010 until 2020 or 2022 even. Okay, let's say we will end at 2024, so we expect to have let's say all installation built until that year. So the calibration is a constant process, and at least for the Polish region, we've already accomplished some of the calibration, meaning that we included all installations built until 2021. Okay, I mean, mostly in terms of electrical generation, of course. So the other problem is, of course, I mentioned that Polish system is our main goal, and Polish representation of Polish system in the GRCEU times is very general, because it is one of the regions of the model. But of course, it leaves a room for our contribution. But we can develop the Polish energy system and build on that existing very fine but also complicated model. Also, we find that there are some CCUS technologies, but there's a difficulty in verifying what is the potential of them, how we can apply them in different regions. The availability in the model is also different. Let's say for Poland, some are off, some are not available. Okay, so the overview. I mentioned a few words already, but GRCEU times we use I think the most up-to-date version. This the version from 2021. It is based on the already mentioned ETSAP times model. It belongs to the family of models based on RES concept. RES stands for Reference Energy System. It is an optimization model which is technology oriented. We use the version that is solved by linear program. It is a linear programming objective function which is solved by the CPLX solver. The time horizon in the original model is up to 2060. The user can define the period length, so it can be 1 year, it can be 5 year, 10-year periods. And these periods, I mean, for each period, there is a calculation of activity per year. And of course, capacity is also calculated. But each year is also subdivided, has subdivisions into 4 seasons and 3 diurnal divisions. So we have day, night, and peak. I mean, for renewable energy sources oriented models, that would be not enough probably. But for this project, I guess this is quite fine. Also, multiplication of the diurnal divisions would mean time-consuming computation of the model, because each subdivision would have to be optimized independently. The model covers the old EU 28 plus some countries like Switzerland, Norway, and Iceland. So it is quite a big model in terms of regional. Each region is represented as a separate energy system with connections. Of course, there are connections with other countries, like countries surrounding EU, and the rest is treated exogenously as imports or exports. Of course, we can choose to have single region solution. If that is the case, the model, of course, calculates all those transboundary energy material flows as exogenous. Otherwise, it is like a common market. There are different economy sectors covered, but mostly energy flows and some materials flows are represented in the model. So it is not an whole economy model. This is the role of CGE model. So there are many processes. Not all of them are available for Poland, but let's say 2,500 plus processes and 700 plus commodities in this system. So it is a really complex model, but at the same time, we have a very good already built-in representation of CCS. Also, we have electricity grid. That is my personal interest because I'm an electrical engineer, and most of my past work was on the development of power system generation expansion planning. So we have high, medium, and low voltage networks connected, and of course, transparent interconnections between each countries are also modeled and included in the EU types. The supply sector is also, we have fuel mining potentials, production, imports, exports, as it is a case in such a model, okay? Because it's not something really different from this typical, but of course the number of these technologies representing is really impressive. And also we have implemented already CCS technologies that we would like to have represented in this. So generally we have different sectors like iron, steel, ammonia, cement, glass, paper. These are the most from the industrial side that most covered by the CCS or CCUS technologies. Supercritical coal, IGCC, CHP, electricity generation that generates some CO2 that can be captured, and second generation biofuels production, biogas and hydrogen production that can be mixed with CO2 to produce other fuels. Okay, so this is generally how it looked like. On the other side, we will have different options to use. So we have CO2 use mostly from here, and possible ways of storing or utilizing CO2 in different options that are, some of them are commonly known. Okay, so the times model, I mentioned already some words how it is done. I try to do it as simple as possible. It is quite typical objective function that is solved. So it is discounted over the whole time horizon function of annual costs, which is minimized. The decision variables are, as I mentioned, capacities, which means the availability, the possibility of each process to produce per year, or maybe expressed in megawatts in terms of electric systems. As a result, we have activities which are also constrained by availability factors, emissions, plus some derivatives of those basic, okay, because these are basic, I would say. What we put in is the information on technologies, technology data, technology characteristic, potentials, energy potentials, processes, like energy flows, efficiencies, any limitations on the capacity and any limitations on the resources. That is on the side of the user. Also, some policies can be implemented in this way, because it is also quite an economic model, because we can actually simulate some implementation of policies. What we obtain is, as I mentioned, technologies, activity and capacities, costs, and emissions, mostly. There are also some materials, as I mentioned. They are sometimes needed because they are natural part of the process, of the energy processes. But of course, it doesn't cover the whole economy. So what we have done to extend this model. First of all, we extended the time horizon, because the time horizon envisaged in the CCUS project is 2070 for this model. So that was just a minor, let's say, change, but also maybe not necessarily big change was the nuclear race-based update, because originally they said that the nuclear power plant should be ready, let's say, within 3 years in Poland. While we know that at this point we do not have any decision yet. Okay, so maybe 2030, 2033, well, 35 maybe, so more realistic. Okay, for the needs of connection between this energy system optimization model and CGE, we also had to create some aggregates. That was the work by you, my colleague Jurent, who identified possible common ground for the technologies so that we can supply some information to the CGE model. Very laborious was this part. This was, let's say, in cooperation with CCUS project participants. We prepared the databases on the CCUS technologies, so to say what technologies are already in the model. But this was quite a big part. So we had to construct the database of the existing Polish power plants and CHP plants. So the first is maybe the data are available. The other is more difficult to obtain and more difficult to let's say calibrate, but we've done it. So they are added as a component. In an original implementation, lignite thermal is represented as a single technology, which is available for each region. While we decided to divide them in different ways. So first of all, the first level of disaggregation is by plants, but actually the actual level is each unit is represented in the model. So from the point of view maybe of such a long-term model is maybe pointless, but it is quite easy to identify in which year the unit will stop, which unit is CCS ready maybe, so which unit would be a possible area of application of CCS technology. I mean, this requires some additional modeling approach because Pavel mentioned that there are different plants, so we have to identify which technology is actually CCS ready, which could be a potential project. Okay, so scenarios. There are two scenarios that we prepared. There are some common assumptions for all scenarios. These are, of course, concerning energy service demand, fuel prices, and building stock. Building stock actually is quite important because it is the demands are not demands for energy carriers, but the demands for energy services which create demand for energy carriers. In terms of CCUS, okay, technologies related to CCUS not enter the market before 2030. CCUS technologies are allowed, but the main of them are production of diesel, kerosene, combining hydrogen and CO2, as you will see later on, and geographical underground CO2 storage only possible in some countries. So what are the differences between two scenarios? Baseline, actually, the emission target is between 1990 and 2050 is 38%. So there's not any specific effort related to reduction. This is the baseline scenario. With CCS scenario, we decided that we will adapt one of the scenarios, zero carbon with CCS, and this is actually the complete reduction of CO2. And CCS technology are allowed. Instead, in order to let's say facilitate its market entrance, we actually switched off PEM electrolyzer technologies. We'll work on that, of course, because these are initial. So to speed up a little bit my presentation, I will go through to, let's say, initial results. We have base and CCS scenarios here. CO2 sunk in kilotons per year for each period. Please treat it as initial results. We only demonstrated that it's possible to let's say to have some such results, and we have different technologies that I will try to decrypt here. So this is direct air capture. This is industry ammonia advanced technologies capture. These are cement dry production. These are glass hollow, recycled glass hollow, iron and steel blast furnace gas, and in pulp and paper high quality pipe and paper production. So these are major technologies here. So we can see that only ammonia and iron and steel here contribute here to the CO2 captured in base scenario. In CCS scenario, we have much higher activity, of course, because except for of this direct air capture coming here, we have cement dry production plus some addition of different technologies. On this here, in this right column, we have fuel generation. So we have hydrogen production from biomass, coal, biomass gasification, coal gasification, second generation biofuel, Fischer-Tropsch diesel production from lignocellulose biomass, ethanol production from lignocellulose biomass. So you can see there are different options, but not all of them are, of course, chosen. Mostly the coal gasification here enters. And here we have the addition of diesel production plus this is hydrogen production from okay, I remembered, but I cannot decrypt every name, of course. Okay, so the other shows industry and fuel generation. Again, baseline and CCS. Since there is no storage in baseline, we decided to place the agenda here, so you can see that there are some technologies already chosen. This is mostly this sink. This is deep saline aquifers. Okay, so this is the highest potential. Of course, we would have to apply some limitations that were already discussed because it is quite optimistic in terms of storage. So this is the major task ahead to parameterize this model. Okay, let me hand over to Michał.
Hello, I'm Michał Waszek. It's my first engineering conference, speech at the engineering conference, and probably I'm the only macroeconomist here. So I will try to give a big picture of what was shown by Paweł, by Martin, and what I will tell by myself. So CG is computational general equilibrium model that looks in a complex way on the entire system. So for example, Paweł said that we can have direct air capture, which is fueled by wind power plant, and it makes sense. And if it's powered by coal, it doesn't make sense. We can put it into Times model and to say, okay, direct air capture powered by coal is not entering as inefficient technology. Wind power plant is entering because it's efficient. And I might say that producing windmills, wind power might be costly and is also emitting carbon dioxide in China, or it's just imported footprint. So that's why we need the third part of our analysis. So we know technologies, the technologies, we can put them into optimization model and say, what's the energy mix, what's the emissions, what are the technologies that are optimal given constraints and given assumptions about demand, but we can put it into macroeconomic model. So usually it's a so-called top-down computational general equilibrium model that looks at different sectors of the economy, at factors of production, and we can simulate this kind of model to say whether introducing CCUS is beneficial for our economy, whether it's worthy to. So for example, Paweł is saying, okay, capturing 1 megaton of CO2 is 100 euros, and we can pay 80 euros for ETS. But I can say, but ETS we are paying and it goes to EU budget, and CCS is produced at home, so we have wages, we have value added, and even if we pay more, it could be beneficial at macroeconomic scale, or maybe not, maybe other way around. So this is why we need a top-down model to have these feedbacks. So I'm saying here about three kind of feedback from bottom-up considerations, top-down considerations. First of all, in CGE type of model, we have direct demand, for example, substituting renewables by coal CCS leads to higher demand for the mining sector, and mining sector is here in Poland. So we have employment in the mining sectors. This is one direct effect. And indirect effect is through relative prices. So some goods might be cheaper or more expensive, and we choose those that are cheaper. So if we introduce CCS, some production might be cheaper, for example, in cement industry. So we can industry that will survive CCS because there's no alternative, or because it's going to be cheaper. And the third one is transfer of resources. So if we decide to build a CCS sector here, and our coal plants are going to stay here, so we will require more employment, and this employment will not be free to another sector. So we need some capital to build this infrastructure for CCS, and this capital will not be available to other sectors. So there is this third channel, and the question is whether it's worth it to invest in CCS or not. And I should add that we are finalizing to build this CGE model. So the result that I'm going to present in a moment is like a first very preliminary results, but they definitely will be different when we are already done with the model and when we merge the model with times that was presented by Marcin. So just a quick look what's CGE. So we've got about 30 sectors of the Polish economy, and in each sector to produce anything you need to have intermediate input from other sectors. It could be from home and abroad. You need primary factors like land, labor, capital. We also have a separate electricity supply, which is important here. We've got ETS costs, which are important here. And in the final version, there's going to be also CCS sector, which will be disentangled as a place when the CCS is, how to say, it's not produced because it's hidden underground, but the CCS service is provided in this separate sector. So we need to build this kind of model. So of course, this kind of models are over there in the literature. We decided to use Orani type of specification, which is in Gempart software, and we develop it and adjust it for the conditions of the Polish economy. If you think how it's organized, there is something like supply and use tables that are provided by Polish Statistical Office and also Eurostat, and then you've got 78 sectors that are producing and supplying some goods. Other sectors are using this goods, so you've got supply and use table, and it's very detailed. So it's organized in a way that can be transformed into this kind of structure. So we see the flow of every one Polish zloty that is produced in our economy, how it goes through other sectors. And for example, if we decide to develop CCS sector, we will see that some other sectors will have higher demand, that will need employment, capital, and so on. So it really helps us to see how the entire economy operates by developing this kind of new technologies, which is quite interesting in a sense that after all, so you might present your technologies, but at the policy level decision, so the key question is it good or bad for our economy? Better to pay ETS or maybe to produce CCS services here in Poland. So what we have done so far, there were a few challenges, and few challenges are left still, but we are very close to solve all of them and to make everything operational this year for sure, and maybe even it couldn't be earlier, but earlier than at the end of this year. So we've got 77 sectors in original supply and use tables. Then we work quite heavily with Times team to have common ground and to aggregate them to 24 sectors that they are exactly the same. So the same definition in one model and the second model. It took us some time, and then we've got electricity sector, and this is a huge problem in CG type of analysis, that there's one electricity sector, and you need to disaggregate this sector into different sources of electricity generators. So we created this kind of infrastructure and this challenge. So this is like for a separate paper, but in general, this is important because if you produce energy from coal, so your policy recommendations are going to be totally different than if you produce your energy from wind. So, for example, direct air capture, perfect solution to use unstable renewable resources. So when you've got energy, you just capture carbon from the air. It's like, and if you have to produce it from coal, so already what you said, it doesn't make sense. So the same with electric cars. So it's nice that it's not emitting, but then we need to produce this. It all depends what kind of electricity grid you have in your country, and this kind of analysis can do within CGE. So for now, we started with this CCUS to not create a separate sector. We started to separate our electricity sector into 7 types of energy. It's coal with CCS, gas with CCS, biomass, nuclear, and renewables. So at the very starting point, we have very low shares, almost negligible share to start with something, because the model works on dynamics year on year. If I start with 0, I will end with 0, whatever dynamics I will put on that. So it's like very low. And the same with nuclear. So this is how you do. And then we try to push a little bit of CCS in the electricity sector to see how this will impact our economy. So the second thing we had to do, so I call it challenge here, so is to introduce the emission accounts and to link these emission accounts to our 24 sectors, which needed to work a little bit, and it's integrated with time. So that's like something that we have to handle, and we've got emissions, and these emissions are costly. And for each sector, we've got a coverage by ETS. So there are sectors that are not covered by ETS. There are sectors that are covered in 70% by ETS system, and we can really follow emission accounts in our model. So that's already solved. We also added dynamics, so we need to solve it till 2070. So in general, CGE models are usually a static one, that when you start, and then you need to add these equations that if you are borrowing, so you are in debt. If you run budget deficit, so you've got public debt. If you need capital, you need to invest, and you accumulate this capital, and you've got rate of return that needs to be higher to invest in different sectors. For example, if you develop a new technology in CGE type of model like CCS, so it looks that you need to invest in this sector. To invest in this sector, you need high rate of return. If you need high rate of return, so capital is costly. So at the very initial stage in the model, developing CCS will mean that it's going to be quite expensive in the initial years, because investors require high rate of return. But thereafter, capital is already there, so you don't need such a huge, because you know how it's working. So this kind of mechanism are there, and we had to predominantly to set how the rate of return evolves on the part of capital accumulation. And finally, this is something that we need to discuss together with Paweł and also with Times, what we call CCS scenario. So this is not exactly what was presented by Marcin. So these two models are seeing each other on many aspects, but these two scenarios are slightly different. Because when we talk about CCS scenarios in the literature, so usually what we see is that you are combining biomass electricity generation with CCS. So this is what you see, and generally this is the main CCS that enters in the papers that you. The key question is why it's so. So is it really so effective in the biomass power plants that CCS is so attractive. And we saw today that it's not so effective. But in these scenarios, you assume that you've got zero emission, and you still emit somewhere. So you need any technology that takes emissions out of the model. So the only is negative. If the only negative emission technology is biomass plus CCS, so you've got a lot of biomass power plants with CCS, which, as a matter of fact, doesn't make so much sense if you really think about whether to introduce CCS or not introduce CCS. So here we are just saying that plants that we already have, like coal-based plants and natural gas-based plants, are in one scenario without CCS, and in the second scenario, we say that there is a strong preference shock. So it's not technological shock, because if you add new technology that is efficient, so you always gain because you can produce more with less. But if it's preference shock, so you're not saying that there is some new technology and you can produce more with less, but you're saying that we are shifting towards a sector. Okay, and this is, I would say, a definition of these two scenarios. So in the first scenario, we've got renewables and nuclear energy that is entering till 2070. So this is usually what you can see in some scenarios of Polish energy transition. Here we don't see much of natural gas. If you go to some official reports from last year, so usually you see a big increase in natural gas, and probably most of you know why now natural gas is not so attractive on the transition path. So especially in Europe, we now see that you can be caught in the middle of transition with a lot of natural gas in energy mix and very high price of natural gas. And this is the alternative. So we see that there is a lot of CCS in coal industry, and it's on the expense of this renewables and atom energy. Still, you can also see that here we've got emitting sectors, and here this emitting, the share of natural gas and coal that are emitting is lower. And we can look in CGE what happens with sector demand for sector, and we can then go back 2 times and say, okay, if we change energy mix, so there's going to be a higher demand for mining sector, because still coal power plants are there with CCS. So this is domestic sector. It requires activity, and if we've got higher activity in the mining sector, we've got also higher activity in other sectors. So it's like going around. Instead of, I would say the main channel of transmission that we see here is that instead of paying ETS, because we emit, we produce here more in the mining sector with CCS coal power plants. And there are some effects on our GDP. So we've got technology that is capturing. So we've got a little bit less of, it's like on levels. So it's not year on year change, but it's in total. So we see that because of CCS, we've got low emissions, but then it returns because with the entrance of nuclear and renewables, so this gain is diminishing over time. And also we've got on the transition path, higher level of GDP, higher employment, because we still save our, but as I said, this is very preliminary, and I don't treat it as ultimate. So there are some challenges ahead to end our modeling phase. So I would say these are these 3 perspectives that very engineering part by Paweł that we try to acquire within the project. Detailed information on every process. So how this CCS is costing, how it's entering. Then if it's introduced 2 times, we can see how it's optimized over the entire energy flow system. And then we can look at feedbacks. What's the big picture? We look at the entire macroeconomy. So in the energy system modeling, on the power side, you already heard what are challenges ahead. So maybe Marcin will say a few words about this energy flow model.
Like what's in prospect for the phase B. Generally, we'll still have to work on the calibration of data. We've already made it for the electricity sector. I mean, heat probably requires some refinement because it's not a very well documented sector, at least from the point of view of individual plant. What else? Data inputs. Of course, we have to work on that because as you could see, we have to, let's say, be in line with typical model inputs. We have to be in line with the general project outcomes. So what are the emissions, CO2 emissions? What are the share of captured CO2 emissions and total emissions that we would have to work on? How this outputs of the model will be placed as an input to CGE. Also importing data on the dynamics of the value added. This is more economic, some economic drivers so that the two models are cooperating, refining the CCUS scenario. Okay, so generally, as you could see, we have some results, but it would be much better if we have these results based on what is the outcome. This also requires some refinements. Let's say, for instance, modeling this retrofit. Okay, retrofits. We actually have to deal with this, and we have to find an approach how to model this retrofit, because for now this power plant database does not assume any retrofit to the existing power plant. So we will have to work on that. Let's say point, which technologies are to be retro. Okay, and then soft link and iterative solution of CG and four times models, because that's how we do. This is not a hard link, where two models are inside one structure and both optimized at the same time. We have to optimize one, then place the input to the other, optimize the other, and seek for convergence. Some difficulties that might be encountered. Combined heat and power plants. I mentioned that we've already made a database. We aggregated them fuel-wise, so based on fuel input. I'd say that if we point that there is the database is created in this way, that if we, let's say, point that certain CHP plant is CCS ready or CCS possible, then we can actually disagree in this. So it is still a room for that. Also, regionalization of use of production and storage of CO2. I guess at this point we will leave this model as it is. And if there is, let's say, specific project that is going to be implemented, we will certainly have tools and possibilities to implement this in this. But this will be mainly as some kind of a simulation. Okay, so that's is the idea that we agreed some time ago when there was one of the meetings. Okay, so when there is data on the CCS cluster, or there is specific technical specification for a pipeline and storage, we can actually reflect it into the model. But at this point, let's say we will stick to, let's say, more general structure of the model.
So plan for this year to end with the development stage of two models. So as for now, they are more or less separate models that are developed jointly, so that we can move to the stage soft link models. And the scheme is below that. We've got CG that is saying to what's the demand at the sectoral level. This demand is then optimized in terms of energy use in times model, and from times model we've got detailed information about energy mix, about ETS payment, about CCS use at sectors. Then we go back to our model, solve it once again, and iterate till convergence. Usually it's 3 times. There is also a quite nice literature on merging CG and models in the literature. and we already almost have the infrastructure to do this. Here on this graph, there is also something like integrated and hard-linked models. So usually these are smaller models, and soft link is like a dominant part. So read about some scenarios about energy mix and emissions till 2050, generated by many international and domestic institutions. So usually they are done with soft link models, and they are called integrated assessment model, climate integrated assessment models. So this is what we are working and doing. And the last slide from my side. So also something that is at a very advanced stage. I would say that early October, mid-October, it's going to be this version of CGE model that we've got CCS market. So CCS is produced as a separate sector. So we disaggregate energy sector into generating, into distribution, and into CCS, which of course at the very beginning will be very tiny, almost negligible, but not zero, so that we can start with something. And we need to calibrate it in a way that it's robust. And then we'll have simulations, I think, that this year that will be here. It would last like very preliminary results that looks that CCS is from macroeconomic point of view something that is good for our development or GDP. But we need to dig a little bit deeper with a separate CCS sector to see which sectors are really gaining or not, like cement industry. To use all this detailed information that we got from Paweł, CG model, and to just show a big picture for why it's important, because at the very end we've got policymakers and investors, and of course the success of the entire project is of course a nice analysis that we do, but I say so it's like what Paweł should say as a leader of the project is that it's really succeeded if we see a CCS cluster here in Poland that is operating, and a big picture is definitely needed for policymakers to explain that. It's costly, but if we look from macroeconomic perspective, it's costly, but it's good for the economy as well. I think that I can stop here and show the last slide.
Thank you very much for this presentation. You could all see that our work in between IGH University and the Visa Europe Institute is somehow combined. We're trying to find a common ground in terms of discussion of how we can both use the knowledge from each of the work packages and each of the working group in our work, and in our goal, which is, as was mentioned already, get the CCUS cluster in Poland, first by providing a proper policy and a legal and regulatory framework. And this is already happening besides our project, actually. So the starting point for the models, for example, could be the projects that are right now being funded in Poland from the EU with the EU support. First of all, is the project of common interest, the Poland EU CCS interconnector project, with the promoter Air Liquide Poland, and it includes, for example, the export-import terminal in Gdańsk. And the launch declared is middle of 2026 with a quite significant CO2 storage capacity, including the CO2 transport infrastructure with buffers, and the newly acknowledged project, the Kujawy Go for EcoPlanet from Innovation Fund. This is the end-to-end CCS project in cement industry with, again, Air Liquide technology, CryoCap FG capture technology, around 1 million tons of CO2 per year. It also claimed to get the CO2 negative cement plant and the promoter is Lafarge Poland, and the declared launch is 2027. So we can see that already there's some kind of CCUS project are getting acknowledged in Poland and are receiving a support in terms of funding from the EU. Hopefully they will be actually introduced and implemented, and hopefully they will finalize the funding from the EU and maybe also get some kind of support from a state. But I would like to also state that what we are other activities in terms of CCUS in Poland, and especially looking from the perspective of Center of Energy at the AGH University, where we gathered the experts in the CCUS technologies I mentioned before. So besides the strategic research and development project that we are talking about here, the CCUS.pl, we are also doing a feasibility, commercial-based feasibility studies for specific industries. First of all, it's for the power sector, and the second one is for the cement industry. And of course, I will not be sharing any details about the actual results of the projects, but I would just like to mention what was included. So in a group of consortium, including AGH University, but also Oil and Gas Institute, Polish Geological Institute, the Institute of Chemical Processing of Coal. Right now they have a little bit different name, although I don't know what it's in English. And the Central Mining Institute, we did a job for the Polish Power Plant Association that was wrapped up some time ago. And it was devoted to the specific analysis of pre-FEED for 3 modernizations, one at Kozienice Power Plant, the other one in Dolna Odra for the plant that is right now in construction, and the combined cycle CHP plant at Włocławek Power Plant, also gas-fired. So 3 details pre-FEED studies, including not only the CO2 capture, but also the CO2 transport routes and CO2 storage, as well as new build analysis for IGCC plant integrated with CO2 capture at the location of Łaziska Power Plant. And of course, the 5th case study includes only the CO2 transport infrastructures from the CHP plant Żerań. They had their own study regarding the CO2 capture, which has provided the knowledge in terms of how to transport, where to transport, how much it will actually cost. So those analyses have been done. This analysis has been done, and lately it was also accepted by the funder. Hopefully, they will start sharing the outputs of our study with the general public, as we get very interesting findings from this study. The second study is the pre-feasibility study for integrated CCS implementation in cement industry in Poland. But this was done in cooperation with the Institute of Chemical Processing of Coal and was funded by the Cement Producer Association. And we just wrap it up. Actually, the reason why some of the people are not here with us today is they had the final meeting today, actually. But what I wanted to say is that we did the process analysis for different CO2 capture routes in reference cement plant. Then we put it on the level of scaling to all cement plants in Poland, the process economic factors. And then we proposed an actual clusters with the selection of transport roads and storage sites. We did a full economic analysis and the strategic guidelines for CCUS implementation in cement industry in Poland. This was done specifically for their case, for the whole cement industry in Poland. We are redoing similar analysis in our project, but usually we try to have a not dedicated to one specific sector, but our cluster will merge power with cement, with, for example, steel plant. So we are looking at the cluster as a multi-industrial application. Here it was dedicated just for the cement industry, as it would wish to go along. And what we also established is within the project, we looked at what is the potential for CCS in Poland. And at the end of the day, we can say that the power sector itself can provide us up to 35 million tons of CO2 per year. This comes from coal-fired power units, mainly the new ones, and the gas-fired power plants, also the new ones and plans to be built. So we are talking about something around 15 CO2 capture installation located all around the Poland. So we need to create a couple of hubs that will integrate this CO2 and put it to the storage locations. This refers to an actual power units that are technically feasible for a CO2 retrofit. We're not talking about all the power plants in Poland, not the old ones. We're talking about mainly the new ones that have the lifespan still yet of 25, 35 years, right? And in the industry, the potential is also significant. I will just reflect the industry of cement, something around 10 to 15 CO2 capture installations are located around 2 or 3 CO2 storage hubs, and something around 12 million tons of CO2 per year that could come from this. So in general, we already have something around 15 million tons of CO2 per year. But if we look to other sectors, depending on the scale, depending on the interest, we can count to additional 50 million, so total up to 100. This is a really significant number in terms of how much the CCS is right now feasibly, technically feasible, and probably at some point also economically justifiable. And what should be the next steps for the CCUS in Poland? Just to wrap it up quickly, we are hoping that we will see finally a full CCUS chain demonstration. But the demonstration, not as the projects that were mentioned, but we would like to see the CO2 transport via pipelines and the CO2 storage in the same information onshore, as this is the long-term scheme, target scheme for Poland. The CO2 capture can come both from power or industrial sector. It doesn't matter that much. It would be great if it would combine those two in one small cluster, but the minimum capacity that we strongly believe should be met is around 1 million tons of CO2 per year. And we should be ready with this by 2028. So by 2028, we should be able to say that the first million tons of CO2 was stored safely in the onshore location. For the CO2 utilization, we're talking, of course, about a smaller capacity and probably focusing on the synthetic fuels. These are our way of thinking about how the CCS should go forward, but we have also colleagues here today from Visa Europe Institute who will tell us about their other project, the CCS4CE, so a project dedicated to developing a roadmap, as I well understand, for the Central Eastern European countries. So I will give the floor to our colleagues.
Yeah, okay, thank you. My name is Kamil Laskowski. I'm from Visa Europa, a junior analyst at Visa Europa, and I lead this project CCS4CE in our organization from the export side. Yeah, and this abbreviation stands for Carbon Capture and Storage for Central and Eastern Europe. And this project is much more like policy level. So it is much less specific in terms of numbers and models when compared to what our dear colleagues have already presented today. But what we aim for is to design an enabling regulatory and policy environment for all these models to work in Poland and finally also in our region, Central and Eastern Europe. So Visa Europa has been just briefly introduced by Michał and in your presentation. So I just stress that we are a lead partner in this project. The main goal of which is to renew the discussion in our region on carbon capture and storage, because it was much discussed, for example, a decade ago. Yeah, when the European Union passed the CCS directive, etc. But this topic is coming again into the debate as together with the European Green Deal and European climate policy. So we want, with the transnationality as an added value of the project, to combine and to join our efforts to make the use of synergies between countries from our region to implement CCS, to deploy it successfully in all partner countries. And the project covers, as you can see, all our region, also with Ukraine. Unfortunately, upon the Russian invasion of Ukraine, we had to somehow stop halt the analysis of the potential of this country. Yes, so we did not already develop a roadmap for the Ukraine, for the deployment of CCS in Ukraine, but we have assessed the potential for CCS, which could be used when the Ukraine will be recovering after the end of the war. Yeah, as I already said, Visa Europa is a lead partner in this project, but we are proceeding with partners from Baltic States, Civita, from Romania, EPG Energy Policy Group, and from Czechia, Institute for European Integration. Our expertise partner is Bellona Europe, Norwegian foundation dedicated to the deployment of CCS in Europe. And the project has 3 phases. As I already mentioned, we conducted an assessment of current state, past experiences, and potential for CCS deployment in CEU region for all countries separately. There was a set of dozen reports, one per country. And following this task, we developed policy roadmaps for each country covered by the project. And finally, as this phase has been already concluded, we are moving to the next phase, which is going to be intensified over 2023, which is dissemination of our findings from the assessment of current states and from policy roadmaps. And our aim is to thanks to disseminating and implementing this knowledge, to encourage policy and decision makers to make CCS work in our region. Yes, so why is this project? We found that CE, Central Eastern Europe, is very promising in terms of CCS deployment, especially since large carbon-intensive industrial base is a greater share in the economy of the region compared to the rest of the European Union. And by this carbon-intensive industries, I mean especially cement industry, steel, chemical processing, oil refining, ammonia production, fertilizers, etc. And given that, we can also see that preliminary finding of CO2 storage sites results in quite promising forecast for underground CO2 storage in our region. So we can afford CCS in terms of CO2 storage because we have sufficient underground capacity. However, as Pavel Gladish already said when he was referring to this global CCS Institute CCS Readiness Index, there are especially policy obstacles. Yes, our region performs very poor in terms of policy readiness for CCS deployment. Of course, it is also visible at the level of regulations. In some states, CO2 storage is prohibited at all. In some states, it is allowed only offshore and not onshore. And stakeholders also complain that there is lack of support from the state in terms of finance, and our society is also, there is also shortage of appropriate knowledge of carbon capture and storage in the society, which can possibly provoke problems with implementing onshore carbon storage sites in the region. And then we come in with our roadmaps how to overcome these obstacles. And key common recommendations from national roadmaps is definitely first mapping CO2 storage sites, because as we found, the assessment, or which is a prerequisite for the deployment of carbon storage sites, is at a very immature level. Yeah, there was, for example, an assessment of geological potential in Poland between 2008 and 2012, but it should be deepened. It is not sufficiently thorough to allow to map the storage sites. But there are also countries which perform even poorer in this aspect. So we definitely firstly have to know how much CO2 we can store in our region before we step in the next phase, carbon capture and definitely CO2 storage. Another recommendation is to launch knowledge platforms to spread and to exchange knowledge, not only on state level, but also at the regional level, because as we found that, for example, Poland is a local regional research hub in terms of CCS when compared to other CE countries, but this knowledge has not been shared enough in the region, and we find this potential to share this knowledge and the research findings with other states through such CCS dedicated platforms. Of course, we also need a strategy from the policy level, yeah, from the national, from the government level, but also from the below. Industrial associations should develop their own strategies, including carbon capture and storage. Yeah, we also insist on changes in regulatory framework, not only national regulatory frameworks, but also international provisions of the international law, as for example, London Protocol is an international agreement which somehow hampers export of CO2 to other countries and to the sea, and this issue must be solved at the international level. And in terms of CCS clusters, hubs, which is somehow related to the CCUS.pl project, we identify potential for making transport hubs in our region, for example, transporting CO2 to coastal countries, from which this CO2 could be further transported to storage sites in Norway, for example, in the North Sea. Of course, these CCS clusters can be beneficial in terms of costs, because shared costs reduce the risk for single industrial emitters, for example. Something has happened with the map, but okay, it is not maybe so important. We also developed a separate roadmap for regional cooperation, and just briefly on the case study of Baltic states, I will try to briefly present key findings from this roadmap. So, for example, Estonia and Lithuania have very limited underground CO2 storage capacity, and on the contrary to Latvia, which has a significant capacity to store CO2 underground, especially offshore. So then we find a possibility to transport this CO2 from Estonia and Lithuania to Latvia, where it could be stored offshore. But we meet this obstacle, which is that Latvia prohibits CO2 storage over its territory, and to make matters worse, even the export of CO2 from Estonia and Lithuania to Latvia is not allowed under London Protocol. So we strongly recommend to harmonize national legislations and allow for underground CO2 storage. For example, Latvia, to enable and support cross-border infrastructure cooperation with the use of European funding for projects of common interest and important projects of common European interest. And at the international EU level, we recommend to jointly act for necessary amendments to international and EU legal provisions. And the next phase, as we are moving to the next work package, as I mentioned at the beginning of this presentation, is to make an impact. Yeah. And our main goal is to somehow influence the law-making process in partner countries. This is one of key performance indicators of our project. We already made a first step in this field, as we already submitted a consultation letter to the Ministry of Climate when the proposal for amendments to the geological and mining law in terms of CCS has been published. We took part in the consultation of this draft law. We will conduct consultations and bilateral meetings with representatives of ministries, engage project partners and project stakeholders to facilitating national, regional and transnational initiatives and events in the field of CCS. And we also aim for signing a letter of intent from representatives of different groups of stakeholders, from industries, NGOs, etc., in order to facilitate, accelerate the deployment of CCS in Central and Eastern Europe. We also count on making use of the synergy with the CCUS.pl project. So I believe that we are on track, we will be successful, and please visit we kindly invite you to our website where you can find our publications. Please follow our events. For example, at the beginning of September, there was a project conference in Brussels. And this was all on my side. Thank you very much. Isabella Fortunakis, project manager of this project in Visa Europa. Thank you again.
Thank you very much, Kamil. It is always a pleasure to see that there are other activities in terms of CCUS happening parallel to our project. And the perspective that the project provides in terms of Central East Europe gives us additional options, for example, to investigate options for trans-border cooperation, also in terms of clusters development. And so just to wrap it up, our project sessions on the CCUS cluster and summary. So one of the main goals of the project is the preparation of the first Polish CCUS cluster, so establishing an organization, and we in a way did it already in March this year. We signed an agreement letter between the HGH University of Science and Technology and the Visa Europe Institute, and we've asked as the founder of the cluster. And during the phase B of the project, so which will start in a couple of weeks, we will foster the cluster development and use it as a main platform for project outcomes dissemination and the Council for CCUS strategy development. So this is our way to trying to get everyone on board in the discussion. The cluster actions are important from the perspective of the Gospodstratek program, which we received funding from. And we wanted to be a place where national and international partners can contact each other through us or individually and try to foster the discussion on the CCUS in the CCUS. Of course, the wide range of stakeholders is available. We have companies, government and administration units, selected NGOs in the industrial association and other clusters. And so we will soon start to get start gathering the access letters from the potential stakeholders. And what I'm planning to do within the cluster activities within the project, well, it's going to be a place for open dialogue. We will also provide an individual support for CCS and CCUS clusters, not only on the commercial basis, but also on a certain level, of course, much less detailed, but also on the project's support for specific cases. We will have a lot of consults, especially we want to be a platform for consults for the CCUS strategy and legislation. That's going to be the outcome of the project. So to give the opportunities to all involved stakeholders to talk through us how they see the strategy and legislation that is planned. We also have several dedicated seminars and conferences planned within the next 18 months. We will also, of course, as we are on the scientific conference, it's worth mentioning that we will have a massive open online course about the CCUS technologies divided into several groups that will be first of all addressing the Polish students in order to learn more about the CCUS in an online course. We'll of course have the newsletter and progress reports as well as knowledge share to general public. In terms of more specific activities, we will definitely develop a database for planned CCS and CCUS projects in order to help the ministry and central government to get the knowledge about what is happening in this field in Poland. We will definitely try to unify approach to public consult about the CCUS legislation on Polish and EU level, as well as we want among our stakeholders to develop an actual cluster. A cluster meaning that we want to find five locations, 5 power industrial installations in Poland and try to build an actual cluster out of them. And we'll go through all the options that are available. So going through from the process modeling to the assessment, and maybe what was discussed, we can actually put this specific case into the model and see how it actually affects. I understand that the effect might be really small, but it's just the question, is it positive or negative in different areas, right? So something like this, I think, would be very interesting to do, to show the impact and also to get the specific value to a selected stakeholders about how the CCUS cluster could look like. And well, of course, we are not alone in the pursuit of CCUS technologies. There are other initiatives. First of all, the federal 45Q tax credit in the US kickstarted several CCUS projects. There are also several CCUS hubs and clusters internationally. Around 15 of them are planned globally at the current moment. Of course, there are other elements like hydrogen economy and coal gasification and gas reforming are one of the cheapest options for the CCS. So also several projects in this area are happening. When we look at what is seen by the International Energy Agency, we're talking about a significant role of CO2 in the CCS in the industry and power sector. And right now we're talking about 27 commercial operational installations, but the plans already in the projects in the pipeline, let's say like this, are for around 110 million tons of CO2 per year. When we look at the power sector itself, we can see that in Europe, Asia, and America, the projects are happening, and the timeline for them is something around 2025. For the US ones, especially the Europe and Asia are a little bit spread around. But we can see that there are some projects in the pipeline also considered for power sector for which the CCS is still a valid option. And to wrap it up, our session, I would just like to say additionally a few words about the future perspective. So we will definitely open for a dialogue with technology providers about their technologies in different elements of the CCUS value chain. We want to have this database for planned CCUS projects in Poland to get the big picture, to know, to be up to date regarding what is happening. We need definite support from a state in this, and we are hopefully get it soon. We are open also for the ideas for CCUS clusters. We are doing this identification on our own based on the sources, potential storage sites, but we're definitely open for incoming partners who will mention about or share the information about their plans for the introduction of CCS in their installations. And of course, the CCUS clusters, well, we are kickstarting it from next month, and hopefully for the next 18 months, as the activity is planned for the 18 months, we'll be able to build a significant institution that will allow us to moderate the discussion about the CCUS in Poland. So thank you very much for your attention, and this wraps up our special session. Thank you. Maybe actually one more thing, because this is still a scientific conference. And so we would like to just share one slide about the carbon capture science and technology journal of Elsevier. We are really looking forward to anyone who is interested in the CCS from the research point of view to consider this journal as a place to submit their papers. Thank you very much.
Who is the editor-in-chief?
Not me. Okay, we'd like to thank you also our online guests. We had a very nice online participation. We are out of time for questions, but you can definitely get in touch with us online through emails or our contact data or our official institutions. Thank you very much for joining with us. Thank you.